All right, F. Whew! We have a stretch factor. This will look a little bit different. This is a little tougher. So we have a stretch factor of 2. So we have to do a little bit more thinking. So if I would put a 0 in for here, my answer that would be spit out for my y is 0. So if I wanted to set up just maybe a little bit of a table of values, I'm going to say x, and my y, which is going to be 2x squared. So if I have my x as 1, I'm going to have my y being 2 times 1 squared, which is 2. So my coordinate point here is going to be 1, 2. Now this is a little bit different from the other one, because like before, what we could do is if there's no stretch factor, we go up 1 over 1. Sorry, over 1, up 1. But instead we go over 1, up 1 times 2, which is 2. What happens if I put in 2? Well, my y that would get spit out is 2 times 2 squared. 2 squared is 4 times 2 is 8, so the coordinate point would be 2, 8. I would have 2, 1, 2, 3, 4, 5, 6, 7. Oh, I'm just going to create a little one up there, 8. And I just get mirrored on this other side here. So when I draw it, it looks something like this. Ooh, it's a little bit more narrow, but make sure that we don't think of it as an absolute value function. It does not come down to a point. So here with this one, I would usually go over 2 and up 1, 2, 3, 4. But instead I'm going over 2, up 4 times 2, which is 8. Don't forget to put in your scale and label your axes. And so now let's analyze it. So the range is still going to be x as an element of reals. You're going to say the domain is always x as an element of the reals. The range is just going to be y is greater than or equal to 0 as per usual, or y is an element of the reals. The axis is symmetry. That's not different. X equals 1. Sorry, x equals 0. The vertex is going to be found at 0, 0. We're still at a minimum, and that's when y equals 0. X-intercepts, there's only one. That's when x equals 0, or we can say 0, 0. The y-intercept is when y equals 0, or 0, 0. And we're done with that one. Now this one is the opposite. This has the opposite effect because it is a fraction. So it is stretched. It's kind of weird. Okay, it's compressed. Or we can say that it's stretched by a factor of half. So essentially what we were doing before is we were saying we go over 1 and up 1 times the stretch factor in this one. We go over 1 and up 1 times 2, which is 2. Now this one, instead of going over 1 and up 1, we go over 1 and from the vertex, over 1 and up 1 times a half. So we're getting a value like this. So if I were to set up a little bit of a chart of values or table of values here, x and y, but I know that my y is 1/2 x squared. If I would plunk in a 0, we would still get back a 0. But if I would plunk in a 1, I would say 1/2 times 1 squared is 1/2, or 0.5. So then the coordinate point would be 1, 0.5, or a half. What happens if I plunked in 2? Well, I would say 1/2 2 squared. 2 squared is 4 times a half is going to be 2. So instead of going over 2 up 4, I go over 2 up 4 times a half, which is here. Now we can fit 3 on here as well. So I would say if x equals 3, oh, and the coordinate point here would be 2, 2. If I would put in 3, I would go 1/2 3 squared. Well, 3 squared is 9 times 1/2 would be 4.5. So the coordinate point would be 3, comma, it looks like negative 4.5, comma 4.5. So I go 3 over and up 9 times 1/2, which is going to be 4.5, just like that. And now I'm just going to mirror these points. And I'm going to draw my parabola. Whoop. It's easier to draw a more curved vertex point on a compressed. And we know that's still opening up because there's no negative here. The next one, I promise, will open down. So the domain here is x is an element of the reals. The range is y is greater than or equal to 0, and y is also an element of the reals. The axis of symmetry is x equals 0. The vertex is at 0, 0. The minimum is at y equals 0. X-intercept is where at 0, 0, or x equals 0. And the y-intercept is at 0, 0, or y equals 0. Ooh, we have a negative here. So that means we have a reflection that's happening. So instead of opening up, we're going to be opening down. The vertex is going to be the same, but since the negative, we're opening down. So instead of going over 1, up 1 with the parent graph, we're going to go over 1, down 1. Don't forget to put your scale and label your axes. Instead of going over 2, up 4, I'm going to go over 2, down 4. So it looks something like that. So we're getting something that looks like this. So let's analyze it. The domain is still going to be x is an element of the reals. The range is going to be all the negative values, so y is less than or equal to 0. But we still include 0 because that's where our vertex is. Y is an element of the reals. It's just negative. The axis of symmetry is still going to be x equals 0. The vertex is at 0, 0. It's going to have a maximum at y equals 0. There's only one x-intercept and it's at 0, 0, or at x equals 0. And the y-intercept here is also going to be at 0, 0, or y equals 0. So on the mastery check, so on the 4.4, and there are going to be kind of two mastery checks for 4.4. 4.4.1, that's just going to be single transformations. Okay, so they're going to be examples like y equals x plus 1 squared, or y equals x squared minus 5, or y equals negative x, or y equals y equals negative x squared, or y equals 1/3 x squared. So if you need some extra practice, come and grab me. The textbook questions are a little bit more complicated than the ones that are going to be on the 4.4.1 mastery check. But if you think that you're able to graph these sort of single transformations, come on up and grab a mastery check.